So in a nutshell, this is the pipeline for developing solutions. And to give you an idea, well, you will recognize on the left the different flagships. The different icons represent basically the different domains we are working on, and the columns are different levels of maturity. So you can see those 78 projects that we are dealing with at the moment, and where they are, let's say, across this spectrum of maturity and flagships. MAIA is, like I said, well, it's a Tier 1 supplementary research in the multimodality and passenger experience flagship. But the interesting thing is, obviously we have other solutions working on similar topics, and we make sure that obviously there are some coordination actions, some synergies really between the projects, so that we combine benefits, we avoid overlaps, and we can provide, we can deliver more relevant solutions altogether. And now, final slides. I just wanted to come back on this master plan I mentioned before. Why? Because it's a very important piece of information for us. It defines, like I said, our roadmap, for, well, the next 20 years. So it's a very important piece of information for the whole sector, and not just for SESAR, obviously. It's something that that took more than a year in the making, involving all stakeholders, airports, aircraft makers, regulators, academics, everybody was involved, and the outcome of this work is the master plan, and this will be really the roadmap, for the next 20 years. You will see basically the deployment priorities. So those solutions that are already available that needs to be deployed, and when and where, but also the development priorities to fill the gaps and to support the achievements of the overall vision. So that, like I said, this will lead to a number of calls. So if you are ever interested in participating in SESAR projects, I would really invite you to take a look at the documents, and also at another document that's called the biannual work program at SESAR, which give more details about what's coming next. And that's it. So thank you very much. You have my contact details here on this line. So if you have any questions, or if you're interested in anything, please contact me, and I'll be happy to get back to you. Thank you very much.
Thank you very much, Jérôme. Is there any question for the SESAR, the MAIA project officer? So as he said, you can find his contact and reach out to him if questions come up later. But in the meantime, let's dive into the MAIA project directly. And yeah, thank you, Jérôme. Can we have the slides back? Okay, thank you very much. So this one. Good. So now we're going to have a presentation of the MAIA project by the project coordinator, Juan. So Juan, please, the floor is yours.
Okay. Okay, that's it. Okay, thank you so much to everyone for joining. Manon already said, and Jerome, but yeah, thank you again, because I would say that this is a very important milestone for the project. This is like how we conclude this almost 3 years, 2.5 of work and research. So it's a pleasure to be able to share it with you. So as Manon said, I'm going to present an overview of the MAIA project. I'm going to be quite brief in order to give more time for the rest of the partners to discuss the interesting results that we have achieved. So first of all, an overall project view. MAIA, which stands for Multimodal Access for Intelligent Airports. This is under, as Jerome said, under the topic for multimodality and passenger experience. We achieved the level of maturity of TRL1, and we started in June 2023, and we are closing the project at the end of this month. The project takes a duration of 2 years, and we are currently in this 6 months of communication and dissemination. The project partners, we are NOMON, are coordinating the project. Then there is Systemics, TML, and the University of Belgrade, that's technical partners. Polis, in charge of all the communication and dissemination activities, and Brussels Airport as a potential end user of the solution. So first of all, a bit of background and motivation. So I mean, why we need a MAIA? So as you may know, air travel is inherently relies in multiple modes of transport. At the end, if you want to take a flight, go to the airport, you have to take another mode to go to the airport, whether by train, by taxi, whatever. So improving this accessibility is going to improve this door-to-door connectivity, which is key to enhance this passenger experience, capacity, and the environmental footprint. So currently, there are some smart mobility solutions which offer new opportunities to achieve these goals, to improve this passenger experience. However, there is still some questions that remain, mainly in their integration with the other modes, which infrastructure is needed to allocate this kind of smart mobility solutions. So basically, the goal of MAIA is to develop this set of data analytics and modeling tools to support this evidence-based design of these multimodal access services. And here we are in this project focusing on 2 kind of mobility innovations. First, the shared autonomous vehicles, and then the unmanned aerial vehicles. So regarding the project objectives, we started the project by defining conceptual framework. Basically, we identify which are the main challenges in airport accessibility, which opportunities this mobility service have, and also which risks they induce. And well, we do this through deep desk research. We also prepare a Delphi poll with a lot of involved stakeholders. We also prepare a workshop, and we prepare a document with this conceptual framework, which I think it's very interesting and it's worth to read it, in which we identify these challenges, we rate them, we see which opportunities of UAM and CCAM has, and also we rate which will be the impact of this. And then we develop 3 solutions, okay? The first one, I'm going to give a quick overview of all of them. First one, which is MAIA-ENGINE, which is basically a toolset for a passenger-centric implementation of multimodal airport access services. So basically, what we do is to, through different tools, be able to describe the airport access demand, and also to be able to reproduce which will be the passenger behavior when these tools are, when these services are available. So we have developed a set of tools for monitoring airport demand, both coming from sources like mobile network data, in which, for example, we analyze the catchment area of Madrid, or other statistical tools that allow us to have a synthetic demand of the passengers. This is what we do in the case of Brussels Airport. But not only tools for monitoring demand, but also for estimating which demand UAM and CCAM will have in the future. This is a snapshot of some work that later on Behzad will present in the case study that we do in Brussels Airport. Then we developed the second solution, which is MAIA-CCAM. So basically, now that from MAIA-Engine we know which is going to be the demand of passengers accessing in this kind of vehicles, the solution says, okay, so then how my service needs to be in order to allocate all this capacity. So how many vehicles do I need? How the different capacity of the different vehicles is going to affect which demand I will allocate. How the service should be, which will be the waiting time. This kind of aspects that Sebastian later on will present. And the last one related to MAIA-UAM, so it's a vertical site selection framework. So similar with MAIA-Engine, we extract which is going to be the demand in the passengers, the potential demand of passengers taking these vehicles. So now it's okay. Now that I have this demand, where these vertiports should be placed in order to allocate all this demand. And this is made in both in the airport site and also in the urban area. So in the airport site, where these vertiports should be placed in order to minimize travel time to the gate, in order to not interfere with other operations, so on. In urban area, in which areas this should be placed in order to try to maximize the demand that is going to be captured. So, well, very interesting result that will be later on presented by University of Belgrade. And finally, we have applied these solutions to 2 case studies. I already presented some images, but the first case study is in Madrid, which is currently the busiest airport in Spain, with over 66 million passengers in 2025, located significantly near the city and also well connected through metro, commuter, and also urban and long distance buses, and also no major cities with, near Madrid, apart from this metropolitan area. And on the other side, Brussels Airport, also busiest airport in Belgium, but well, the demand is notably lower, also located significantly near the city, and also well connected with Brussels, but also with other near cities by bus or by train. And here it's a bit different because we have also some major populated cities near the airport, which is also interesting to study. So this is all from my side, just a quick overview of the project, big picture, let's say, and then the rest of the partners are going to present the solutions in more detail and the results that we achieved in the project. So thank you so much, and I leave you the floor.
Okay. Thank you very much, Juan. Sure. But we can go on with the program. So we're going to have now a presentation of the results of MAIA, then a short coffee break, then the panel discussion, then a presentation of the white paper, and then it's over, all right? And you're gonna have an excellent lunch to say that we are sorry for that. Yeah, just, okay, so. We were in the agenda here, okay, at the presentation of the project results. And we're gonna start with the presentation of MAIA-ENGINE by our dear partner Behzad from TML. So Behzad, the floor is yours. I'm gonna show your slides. It's this one. You need to switch slides here. You can use either that or that, as you prefer.
I would choose this one. So, hello everyone, and thank you for being here, and sorry again for the delay. So right now I'm presenting the MAIA-ENGINE, which is one of the solutions of MAIA. So the goal of MAIA-ENGINE is to develop a tool set focused on improving airport accessibility through innovative passenger-centric multimodal transportation services. So it has 4 algorithms we have developed together with other colleagues in MAIA. We have developed 4 algorithms for passenger profiling, synthetic population, mode choice modeling, and the demand prediction. as I mentioned, in MAIA-ENGINE, we would like to analyze how the new transport modes would influence travelers' behavior, and we try to forecast airport access to demand. So the goal of MAIA-ENGINE is to, in simple terms, we would like to understand if in future we have urban air mobility and we have CCAMs, connected cooperative autonomous mobility, whether people would use it to access to the airports, and how would be the demand for these modes in our case study, which is Brussels Airport in this MAIA-ENGINE. So as I mentioned, we have developed 4 algorithms: the passenger profiling and airport access characterization, the synthetic passenger populations, which is developed by Systemix Sebastian, and the airport access demand modeling, which is developed by us, and the short-term demand prediction for the new modes of transportation to the airports. But my main focus today is on the airport access, on the synthetic population and the airport access demand modeling. So this is our, as it has been already mentioned, this is one of our case studies and the focus of my presentation. Brussels Airport, it has 23.6 million passengers in 2024 to more than 210 destinations and more than 80 airlines. So what we have done in the MAIA-ENGINE, as I told you, is based on we try to estimate the demand per transportation mode. What we have done is that, we work on the survey of the Brussels Airport. So Brussels Airport has conducted a survey, and in this survey, they have asked some information from the passengers, and together with their transport mode, the mode that they are choosing to travel into the airport. And this is the current modes of the passengers. So majority is the car, then train and taxi and bus. And these are also some other graphs about the distribution of the transport mode per province in Belgium. I'm not going to the details of this. And also we have the number of passengers by hour and transportation mode in Brussels Airport. So these are the results of the survey. But as I mentioned, the survey right now, it's and the modes of transportation that people are using right now to travel into the Brussels Airport, of course, it does not include SESAR and UAM. So what we have tried to do is that we try to estimate and forecast the future demand of urban air mobility and cooperative, connected, and autonomous automated mobility for accessing to Brussels Airport in the future. And for doing so, we should have done some assumptions, and we assume that the people would react to the current, to the new modes of transport in the same manner that we are reacting to the current modes. And also, of course, we have to done some operational assumptions on the travel time and the travel cost of UAM and SESAR. So for UAM, we have assumed a cruise speed of 120 kilometers per hour and the price of €5 per kilometer. And for SESAR, we had 2 types of services. One service is the SESAR Business, which is equal to taxi fare, and the time is also equivalent to car driving time. And we have the SESAR Economy, which is 1.5 times more, taking more time, and the price is half of the price of a taxi. This is the discrete choice model that we have developed. I'm not going to the technical detail of this, but as I mentioned, the general assumption is that we have assumed that people would react to the would react to the new modes of transport in the same way that they are reacting to the current modes of transport. So in order to apply our discrete choice model based on the survey data from Brussels Airport and based on the open access population data, we have developed the synthetic population. So these are the synthetic passengers in entire Belgium. And then we have applied our discrete choice model, which is which I have shown you, to the synthetic population in order to have the new modes of transport demands. So here on the left, you can see the current passenger demand per mode, and on the right, you can see the prediction of the model, including the new modes of transport. And based on our forecast, it will SECAM would have 6.8% of the total demand for traveling to the airport, and UAM would have 4.7% of the entire demand to the airport. And yeah, these are the profile of the people who have, I mean, which mode they have used before introducing the UAM. And so we are seeing that the main UAM users comes from taxi, and we are also seeing that 14% of them comes from car. So based on our study, UAM appeals to time-sensitive and high-income travelers. And also, this is the same figure which shows you from which passengers that they have choose which modes of transport before introducing the SECAM. Right now, which is the profile of those passengers who are choosing SECAM. So 67% of the SECAM users comes from car, and 20% also comes from taxi. And yeah, based on our studies, the SECAMs offers comfortable privacy and and a flexibility like cars. So for the SECAM economy, it's cheaper than the taxi, but more convenient than bus and train. So it appeals to private car owners seeking automation and cost saving. And these are also the sensitivity analysis for the to the time and the cost. And for UAM, it's more sensitive to cost. And for SECAM, the sensitivity to cost and time, it's almost the same. And yeah, these are also the visualizations for the demand per modes of transport. The more red each point it is, the more probability to choose the specific mode. So right now, you can see the demand for a bus. So you can see that for the bus, it's more near to the airport. The demand to airport is more located in the area not far from the airport. Here you can see the demand for the train to Brussels airport, and as you can see, it's spread all over the Belgium. Then we have the car demand, which is also spread all over the Belgium. And we have the demand for taxi, which is more centered around the airport itself, because if you want to travel with taxi from far away, then it would cost too much. So here what is also the model is telling us. And we have the demand for UAM, and for UAM we have done a simple study on how to select the vertiport site locations, and based on those assumptions, we would have more demand in Leuven in Belgium, and in Mechelen and in Brussels, the demand for UAM. And also we have the it's forecasted demand for SECAM users, and it's also spread all around the Belgium, and with more percentage in comparison to UAM. So these are the results of the potential demand for SECAM for a typical weekday in order to travel to airport. So with that, I close my presentation. And in MAIA-ENGINE, we try to have some forecast and estimate for the future use of UAM and SECAM in order to access to the airport. So based on our studies, we think that UAM would act as a more premium time-critical travelers, and SECAM would attract so many people, which act as a mass market replacement for private car users. Yeah, thank you very much, and I hope you have a nice presentation.
Thank you very much, Behzad. We will have the 3 presentations, and then there will be a Q&A session.
Yeah.
So thank you very much. And yeah, Sebastian, you can come to present MAIA-CCAM. You can use this and you will switch slides here.
Okay. Okay, perfect. So I'm gonna present the MAIA-CCAM part of the project. So let's just have a quick look what this is about. So we are talking about CCAM here, cooperative, connected and automated mobility. So which is basically a concept in which we have self-driving cars. They act as a taxi. And in most or many application cases, they are envisioned as a service where people are actually pooling rides. So it's not only individual people booking a ride, but you can pick up somebody else along the way, or the vehicles can pick up somebody else along the way. And usually to make all of this in an optimized way, you control this whole system by a central dispatcher that basically says in which directions the vehicle should move, whom they should pick up, and so on. Okay, so how can we understand these systems? Usually what we do in research now is to use agent-based models. So the idea here is that we really simulate all the individual elements of the system in detail. So we have all the travelers that want to go from A to B, and then we simulate all the movements of all the individual vehicles second by second. And here we see, for instance, in this visualization here, there we have individual cars driving around in a city, and we have these dots, for instance, when the people go to work and so on. So we really demonstrate exactly what the people do during one day, and then we can perform simulations of fleet services as well. This is then the point where we can look into different effects of different management decisions. So what happens, for instance, can I start this? What happens, for instance, if I always tell vehicles to take the shortest path to the next customer, and I always pick up the closest customer to any vehicle in the system, or if I distribute them uniformly in the system, this will have different impacts on how many miles these vehicles go, and what will be the wait times for the customers before a vehicle arrives to pick them up. And with these agent-based simulations, we can really in detail simulate those services and then see how each of the customers that sends a request to the service is treated by this mobility service. Okay. Now what we do in MAIA is to apply this concept of CCAM to the airport context. Why is this an interesting context? Because usually what we see is that the flows are highly bundled. A lot of people go from the city center to the airport and then they go back. And it is also highly balanced. So if we know that that people go to the airport at some point, probably they will also come back. So we kind of have the same flows also in the other direction. This is quite nice, quite a nice use case for such a system because it gives us some kind of certainty where the demand will be and how much demand we will have. So our goal in MAIA-CCAM was to apply the CCAM concept to the case of airport access. With the demand data that you already saw presented by Behzad, and then we do certain tests, checking, for instance, how many vehicles do we need to transport all these people that want to go to and from the airport. Beyond that, we added a couple of components that also allow us to look into uncertainty. So inside of this framework, we also simulate components that you can kind of play scenarios where we have congestion on a certain road, where we have delays, for instance, because there's a flight that arrives late. So all the kind of trips that are scheduled in advance, they have to be rescheduled to a later point in time. or maybe there's also a disruption in public transport that maybe exists for an airport, and then we use this service as a replacement, as a kind of a fault recovery system for public transport. These are all kind of components that we can simulate now with this MAIA-CCAM component. And the general structure is always like this, that we start with a certain set of trip data. So this can come from MAIA-ENGINE, but this can also come from a real trip operator who maybe tracked people go from A to B with coordinates, with certain timestamps. You can put this into the simulation. You can configure the service, so what will be the speed of the vehicles, what will be the maximum wait time that you allow for the vehicles to arrive. And then you put this into the simulator, and then you get these results, for instance, the wait time for the people, the costs, and so on. And all of this is based on open source software. This is based on the MATSIM simulator. So quickly, a couple of results. So what we did here in the MAIA project is now to use this whole framework with two experimentation cases. So there's Madrid, where you already saw that we can generate data from MAIA-ENGINE. So there's there the data comes from mobility service data. For the case of Brussels, this is based on a synthetic population and a mode choice model. Then once we have this demand, we define operating areas. So where people can have their destinations and origins to and from the airport. We then add certain attributes, like for instance, how much time these people need to interact with the vehicles. And then we do our final simulations. And all of this is included in this MAIA framework. So the first case here was Brussels. What you see here is that we get these probabilities or this number of expected passengers from MAIA-ENGINE. We have a certain study area that we defined here. So we have 0.2 requests per square kilometers in this area that we have defined, with an average distance of 38 kilometers to the airport. And this is kind of our set of input data for the Brussels case. For the Madrid case, this is a bit different. So there we have 0.43 requests per square kilometer, so a bit more, and a bit less average distance to the airport of 23 kilometers of all these requests that we consider. Also, we add then certain demand characteristics. So here we split up between leisure and business travelers. For Brussels, we can do this, for instance, directly based on passenger surveys. But we can also apply more kind of statistical generative models. So this is now the repartition of the different user profiles here for Brussels and Madrid. And then we give, for these leisure and business categories, different service characteristics. So for instance, we say that there's a certain maximum wait time for passengers before a vehicle can arrive. Or we say that the service is poolable or not. So in our case that we defined here, a business trip is not poolable. So you will not have another passenger that will enter your vehicle while you go to the airport. Here we see now these simulations that we can run. So on the left, we have this case of Brussels. Then on the right, we have this case of Madrid. We can do these visualizations, but basically what we are interested in is then the final results, which look like this. We do fleet sizing experiments. So what you see here is the fleet size on the x-axis, and we increase the fleet size to the right. And then we see on the y-axis the rejection rate. So how many of these requests do we need to reject because we cannot serve them within the service characteristics that we define. So for instance, these 15 minutes of wait time. And then we just search for the point where we go below 5%. Then we say, okay, this is an acceptable number if we only have to reject 5% of people. There we see we already need a certain fleet size to serve all the business passengers and to serve all the leisure passengers. We then have here on the right certain characteristics that come out. What is the total distance of our system driven? What is the occupied distance? If we do a certain ratio between the customer distance, so all the kind of paying kilometers by the customers divided by the total distance of the system, we kind of get this distance ratio that gives us something about the profitability of the system. So here we have a ratio of 1.55, for instance, for leisure, which means we have more paid customer kilometers than we have driven kilometers in the system because things are pooled. This factor is below 1 at 0.59 for the business case. And then we can compare this with the Madrid case. So here we have similar values. the distance ratios are a bit higher, which means that we have more paying kilometers per driven distance. What we can do then, but this is just the first try here in this project, is to also put a cost model behind this. So if we know what is the total distance driven, if we know how many vehicles we have that we need to maintain per day, we can kind of calculate some costs that either need to be paid by the customer per trip or per kilometer. So these are the last two rows here. Then we see here, for instance, that in Brussels, we would need to pay per leisure trip 2.5 euros. In Madrid, this would already be 3 euros to cover the full costs of providing this service. And if we make a distance-based cost model, we would be at 12 cents per kilometer or 10 cents per kilometer for leisure, and then a bit higher for business in these two cases. So this already gives us an interesting comparison between two use cases. And what we then also did in the project is to look at different operating areas for one case. So for instance, here you see for Madrid, we have the core area there where we see the M. Then we have this southwestern area that we add optionally. And in the table there on the left, then you see what this gives if we add additionally this area to our service without doing a new fleet sizing. There we see, for instance, that the distance ratio goes up. So we have a bit more paying kilometers per total kilometers, but also our rejection rate goes up. In Brussels, we did the same thing in a much more larger context. So we have many different zones. We check all of the combinations of these zones. And then we see, for instance, there in bold, we find one combination where we have Brussels and Mechelen together, which gives us the same rejection rate of 6 and 4%. But then our distance ratio goes up in these cases. So this means if we add this area to our operating area, we have a more profitable service, or we can operate the service at a lower cost just because we add this additional demand. So this is also a tool that really allows us to define where we want to operate our service. And in total, well, this is the first step, this package, but it exists, it can be used. But in perspective, this is something that really can help to anticipate how to deploy SESAR services to connect cities and passengers with airports. So this is open source now, this is also online. So if you're interested in more details also in the application, then feel free to get back to us. Okay, thank you.
Thank you very much, Sebastian. And now we're going to go into the presentation of the last MAIA solution, MAIA-UAM. Bojana, the floor is yours.
Thank you, Maron. My name is Bojana Mirković. I'm professor at the University of Belgrade, Faculty of Transport and Traffic Engineering, and our team was working on this MAIA-UAM solution. So in other words, that's actually a site selection framework, vertiport site selection framework aiming to support definition of the vertiport network in the urban area, in the catchment area, and also at the airport site in the context of UAM airport shuttle service. So first phase of our research was actually collection of the inputs and assumptions, because this is really new field, and there are plenty of assumptions used in previous studies and also published by different organizations. So our aim was actually to collect relevant assumptions related to eVTOL aircraft performance and operational characteristics, also related to potential candidate sites for vertiports, also different parameters related to routes, preliminary routes connecting these vertiports, and other factors that actually are important, that are influential factors to travel time and travel cost, being the key drivers. I didn't do anything, I promise. I still see it on the screen, okay. Travel time and travel cost being the key influential factors when we estimate share of UAM demand. Then we started this modeling stage, and our framework actually tries to give response observing this problem from two different perspectives. First perspective is actually a perspective of micro-location of the vertiport at airport site. This vertiport plays a role of hub vertiport in the UAM airport shuttle service network. And the second perspective is actually this network perspective, when we actually try to offer models for supporting decision about number and location of vertiports in urban area, in the catchment area of that hub vertiport. So first, this is just very brief, but I have to mention this because we really put a lot of effort in this part, considering the time where we started the project and maturity level in the UAM service was at that point. So we conducted detailed literature review, also face-to-face meetings with airport operators and also helicopter operators, considering that helicopter services are the closest what we actually have to UAM service. Then we defined our MAIA assumptions and validated them through webinar and the follow-up survey. So basically all assumptions we are later on using in the models, they are validated through this step, and also additionally at the second workshop we had in Madrid. But we tried to make our models flexible, so it means if anything changes or you would disagree with the assumptions, we can change them in the models, just rerun them to obtain, let's say, more useful results as the assumptions and input data change. So then first, I will start with this network perspective model where we actually defined the optimization model for determining the number and location of vertiports in the city for the whole network. I have to say that actually this vertiport placement problem was addressed so far in many studies, especially for the urban area, but previous studies mainly employed clustering algorithms or hub location problem combination with more choice models. We actually tried to do something different here, and this is original model we developed here that actually takes the perspective of eVTOL operator, and we assume that eVTOL operator is the one who invests in vehicles and also partially in the infrastructure, considering that there will be some subsidies, and aims to maximize its profit. So we basically have two different stages of the model. In the strategic level stage, we decide about number and location of vertiports and also size of the eVTOL fleet. Then in the second model, which is tactical layer, we conduct various simulations, thousands of simulations, to see how the demand materializes, and then that gives us a profit, expected profit of the eVTOL operator. The final aim is to maximize this profit. Also, in addition to this, we assign some risk to the objective function of the maximizing the profit that should ensure that the profit will be above certain threshold for a set probability. The second perspective is micro-location, where actually it's not enough just to define this approximate location of the vertiport, but for the hub vertiport, we aim to observe it as any airfield, which means that a different set of operational, social, environmental, and cost factors need to apply. But for this specific case, as I said, we focused on the airport vertiport. So we collected different also studies previously addressing the problem of location of different types of airports, heliports, very few studies related to micro-location on vertiports, and we come up with our MAIA set of relevant criteria. So for now, and I'm open for discussion later on, we consider that when we decide about micro-location at the airport, what we could neglect is actually environmental factors like noise, visual pollution, and similar factors that are quite important in urban area, but at the airport they're more or less the same if we consider micro-location in the near proximity of the airport, and also land use, land value, they're again more or less the same in that area. So we finally decided to include this model, but it can be expanded for sure. In some later steps, we decided to, based on the available area of the candidate size, to assess its capacity, also cost of the selected vertiport configuration, proximity to the terminals of the airport, like 3 core criteria. We also were aware that we must include safe integration of the vertiports into airport in the aircraft operations. But unfortunately, to this stage, this regulation in this area are quite underdeveloped. Also, there are very few studies dealing with this problem, and we are, as you could hear from our project officer, we are a multimodality project, so it was out of the scope of this project to go into details and develop some procedures for integration. To actually still keep this safety factor in the decision criteria, we approach this by defining a set of soft rules. We considered vertiport location with respect to terminals, with respect to runway system configuration, with respect to city or cities areas this vertiport aims to serve, and only use it with these soft rules to accept or dismiss certain candidate site. For all the location we accepted, then we evaluated them against these 3 criteria. So for proximity to terminals, we calculated the time from vertiport to terminal, considering whether it's the vertiport on the land side, air side, does it use public roads or airside service roads. And also we assess capacity, area of the candidate site we transformed to operations per hour, and also based on the proposed vertiport configuration, we calculated the cost of that vertiport configuration. So for that part, capacity and cost, we developed a tool. It's MAIA, we call that vertiport sizing and capacity tool. If you want to check it, you can access it through this QR code. It will take you to this starting home page with a different set of assumptions. So for the assumptions, we have here eVTOL parameters, vertiport design, vertiport layout, operations, passenger processing, and also charging policy. Why we developed the tool? Because we wanted to make it flexible for future users. So now we have certain set of assumptions, but you can, we use here default values, but you can insert any value you consider more appropriate later on in your studies. So this tool consists of the 2 options. So you can see them up there in the green and blue. So one, which is vertiport capacity and area, it actually based on input data you insert or use default values. And selected vertiport layout, we consider 6 of them that we identified in the literature that are so far used. You can get different area parameters and also capacity values. What is more important in the context of MAIA and the comparison of these vertiports on the airport side is this second tab that actually proposes the vertiport configuration. So it means if we have already candidate sites with defined area that we approximate with rectangle or square, it will return the option among these 6 layouts that will give you the largest capacity, largest throughput under the smallest area. And based on this number of gates area, we can calculate the cost of that option we selected for the vertiport. So I will show you the results based only on Madrid airport case. I will focus on that because we addressed it in more details than Brussels airport case. So for the first model network perspective, we started with 356 candidate sites. We actually decided to observe Madrid community area because based on the results from mobile service operators that were briefly mentioned by Juan before, this Madrid city generates 62% of the airport access trips, but Madrid community generates even 87% of such trips. So we decided to observe this larger area. So it contained 356 zip codes. So in every centroid of the zip code, we assume that starting vertiport can be anywhere in these areas. For the Madrid airport, we identified 10 candidate locations. 7 on the land side and 3 of them on the air side. Their land side is if you're familiar with the Madrid airport, you can see they're mostly on the rooftops of the garages or parking areas, or some already available land which is do not contain any kind of construction. And on the air side, these are portions of the remote aprons. I will not go through the assumptions, but for the network model, we had to set assumptions related to vertiport capacity and vehicle capacity. Also, assumptions related to travel time, including cruise speed, route length and profiles, also additional time at the airport, and also we had to set a series of financial assumptions starting from depreciation cost, revenues, and also profit margin. If you are interested to discuss later on any of this, we can do it during the Q&A session. So for Brussels airport, we had developed more choice model, calibrated more choice model as Bezat presented, but we did not have it for the Madrid airport. So we actually assumed overall UAM airport shuttle service share 1, 3, and 5%. We have it around 4.7 for Madrid from the more choice model. We also introduced some cost sensitivity, which means that areas with higher income intend to have higher usage rate for UAM than areas with lower income. And then for the last thing, we also introduced time sensitivity, which means that this cost sensitivity actually applies only if we have vertiport in every zip code. But since that's not going to be the case, we had to calculate the time travels from each zip code from that zip code and also neighboring zip codes. And we also introduced this willingness to use function from 1 to 0.2, starting from shortest travel time to longest travel time. And of course, if there is no vertiport in any of the neighboring zip codes, probability to use the service is 0. So we did not go further from neighboring zip codes. These are results for the default scenario. So you can see that actually model, you probably all encountered previous studies related to this, and some starting studies were very promising, assuming 50, 75, 100 vertiports around network. Our expectation were actually something similar to results we got. So it is the network consisting of 8 vertiports in the urban area and plus 2 vertiports at the airport. It was really, these 2 vertiports at the airport was something that we expected, one nearby Terminal 4 and the satellite, and one nearby Terminals 1, 2, and 3. And we also got eVTOL fleet of 11 aircraft, and these are profit values for 3 different overall shares of UAM demand, 1, 3, and 5%. So here you can see we named the areas, so you can probably again recognize the area in the central area near the city center and Atocha railway station. Also 2 districts in the center, that one financial district and also business district. So we could actually, we were satisfied with getting these results. It is going along with our expectations actually. We conducted series of sensitivity analysis on cruise speed, additional times, route extensions, cost of vertiports, level of subsidies for vertiports. But it was interesting actually to see that these additional times we varied at the airport that could be trying to include waiting time, average waiting time of the people. So the model was most sensitive on these values because the total travel times were, let's say, quite short. So you can see it here. Maybe it's interesting to see how the profit changes. 5, 7, 12, and 17 minutes. Our default scenario was 7. And we compared it, the green bars are actually benchmark. We used facility location problem to compare our results of our model with that one. So it's interesting, maybe for 17 minutes, that facility location problem is always with negative profit, and our model managed to find locations of the vertiport that actually give some positive profit. And very briefly about the results for the second model. This is ranking of this micro-location at the vertiport, deciding about micro-location at the vertiport. In the first stage, we did not dismiss any of the location because Madrid Airport has really nice configuration with these parallel runways, and all candidate sites have really good position with respect to city terminals and runways, without that you can actually expect operation not to interfere with aircraft operations. Then we actually used our tool we developed to extract for each site proposed vertiport configuration. So from that we had capacity of it, and based on the number of gates and total area and assumptions related to cost, also the type of vertiport, whether it's airside, landside, on the rooftop, on the ground, we could extract the cost of the vertiport. Also, I don't know whether this is unexpected value for you, but in the previous studies we have probably the large networks were result from the very underestimation of the vertiport costs. We are usually served the value around 500,000 up to 1 million, but we actually got the values of couple of millions that these vertiports should cost if someone is paying for the whole eVTOL operator, or airport in this case is paying for the whole construction. This is summary of values for all the location, all the candidates. And finally, we only employed, just for the demonstration, this simple additive value ranking because it is quite easy to understand, not any kind of sophisticated multi-criteria decision-making techniques. Here you can see that for 4 different normalization techniques, we got always the same best vertiport. It is this L5 marked on the picture. Also, if you compare with the results from the network model gives L4, which is just next to the terminal 4, and L2 because it's sensitive only on the time. And if you include other criteria, we can see that actually this position can change. So this is just a start. So that's why we selected all these criteria which we considered as relevant. But I mean, we advised at the end of the project that actually this can be expanded with any other criteria, and especially focusing on something that Muse project will be focused on later. When we speak about the same thing in urban areas, then we of course need to include noise and visual pollution and other factors that are important for urban site. So, thank you.
Thank you, Bojana. Actually, don't go back to your seat because maybe we can have the 3 presenters, Behzad, Sebastian, and Bojana. You can maybe sit at the table for the short Q&A session. What I would advise is that we have now questions for about 15 minutes, then we have a coffee break, and then we have the panel discussion. So overall, the event should end around 1 instead of 12:30. Okay. Okay. So do we have any question yet for the researchers? Yes, I'm bringing you the mic. If you can introduce yourself first.
My name is Ismini Strumpu, and I work for the Technical University of Catalonia. I'm also involved in SESAR in various projects. And my question is, what is the impact of your solution in air traffic management, especially the third one, that I see that it's more related to advanced air mobility?
Thank you. Does it work? Yeah. So as I mentioned briefly, we did not include impact on ATM. neither when assuming the routes in the city, nor with the integration of airports within vertiports within airport environment, apart from this, what we call the soft rules, just trying to avoid that any easily detectable conflict with aircraft operations. Because we are multimodality project, we wanted to try to go into that, but then realized that we're not going to have time to cover what we need to cover from the multimodality perspective. But it is still, I think it's important issue to address before implementation of UAM service.
Thank you. Any further question? Yes.
Tom Eric from MAIA. Sebastian, you talked about costs at the end. What was the input for that calculation?
This was one study from 2021, 2020 from Switzerland, where at ETH they were basically looking at all the different cost components of mobility services, like cleaning, ownership, maintenance, and so on. And then they were basically checking on what would it mean if every cost component is actually seen in an automated context. So the driver wages, they fall away. Maybe you have increased cleaning costs because there's nobody who's supervising the people who are in the vehicle and so on. So this is basically one published cost study from 2020, I think. So we took the values from there and just converted them to euros from here, because I think this is one of the most detailed ones. But I think there's also, I think there's no special case for Belgium, for instance, but there was a follow-up paper with many different places around the world, like also Berlin and in other cities. And I think we didn't have Madrid and Berlin and Brussels in there, but then there's other places that have been analyzed in this way, and there's quite a nice methodology for this. But we also heard that from different operators, well, nobody wants to share their cost structures, but everybody says, okay, maybe it's not exactly the cost structure that they have, but yeah, this is something that you can parameterize, and then everybody can configure it as they think is the right way, and then obtain their numbers.
Thanks a lot. Any other question? Do we have any question online? No. Okay. I actually had a question. In the beginning of the MAIA project, we assessed the airport access from a passenger perspective, and we saw that travel time and convenience of travel is the main criteria for people to choose their transport mode. So to the three of you, actually, how do you expect these UAM and SESAR to impact the travel time and the convenience of travel for air passengers? Yeah, maybe
I want to add to that. Yes, actually, in estimating the demand, that was actually our challenge to understand what would be the travel time and the travel cost of UAM and SESAR. So this is why we have done some assumptions on that. But yeah, the way how I see the UAM, of course, it would need to shorten the travel time, but of course the cost is not that much low, and it is a bit more expensive than so it's a premium service. And also for SESAR, as I mentioned in the presentation, it should be like different types of services. One service like for the economic passengers, and the other services for the business passengers. And for the business passengers, it's almost the same time as the driving, but the cost is the same as taxi. But for the economy passengers, because of the fact that it should pick up other people's, the times would be a bit more than the driving, but the cost is half of the taxi. So with these kind of different services, it can handle so many types of passengers and answer to the needs of so many types of passengers, I think.
I think the important part is also that it's a trade-off. So you can offer services that are really quick with very low wait times. But then on the other hand, the costs will be higher because you need a larger fleet to actually serve all the people in this short time span. So one thing that we didn't do in the project, but which could be a next step, is actually now to feed this back. So for instance, now we did an assumption on the cost and the wait times to obtain the demand in MAIA-ENGINE. Then we simulate this demand with MAIA-CCAM. We get the actual wait times out, we get the actual costs out. So now we could actually loop this back and run this in a loop. So this was out of scope in this project, but this is also something that we did in other research. And then usually what we find is that, well, we can deploy any kind of configuration that we want. Usually we find the equilibrium between the comfort and the cost somewhere. And it's basically just a design choice of the system. So do we want to deploy a service that is quite cheap and accessible to everybody, or do we want to deploy a really quick service, but which is more like in the premium segment?
Yeah, and I will just add up on this related to UAM. So as both Sebastian and Behzad said, for UAM is definitely travel time is short, and it's not sensitive to congestion on roads, but it is premium service, so it definitely comes under higher cost, and it does not affect large number of people as SESAR. So it's still on the premium level, and as I said before, we are happy by the results we obtain. It's really low number of vertiports, and for the start of the service, and a small fleet to serve that, let's say, a very low share of the UAM demand. But I mean, it can expand in the future, but for now, it really affects only small portion of the airport access trips.
I see. Any further question from the audience? Yes.
Thank you. My name is Raghu. I take care of smart cities at GMR Group. We are world's second largest airport operators and aerocities as well. The question I have is that the UAM part, how do you handle the regulatory stuff? Because drones, those things are not allowed within the airport premises. So we are also actively looking at multimodal transits into our airports. Thank you so much. So have you implemented anywhere? So how is it going? That's what we are keen to learn.
Yeah,
Thank
sorry, in what context?
For
related to integration with?
Into our airports, how do the EM thing works as a transit model? Because drones and objects which fly cannot be entertained into the airports as a regulatory stuff. So how is the research going on? How you guys are handling that? We want to know. Yeah, thank you.
Yeah, thank you. I was kind of expected these type of questions. As I said, we realized that the safety is an important factor to include, despite of the fact that we did not have anything to build upon. So we also, for the papers we submitted, we got the main reviewer comments related on this part. So as I said, for the first question, we really did not develop anything in that context here in this project, as it's multimodality project. So we were focused on the passengers and the service that we could attract. But we addressed this issue for now only by introducing these rules related. So we said if the vertiport candidate is located on the same side with terminal complex, not across the terminal and candidate sites are not on different sides of the runway, then we can expect it does not directly interfere with the aircraft operations. Also, if, for example, we had parallel runways that are closed or crossing, it shouldn't be nearby where we expect that aircraft operations must take landings and takeoffs. So we only address it, and also for the city, if the core city is located with the vertiport on the same side of the runway complex, then it should not really be a safety issue for the operations. But as I said, we did not go farther from this. We identified during the course of project a couple of papers that actually designed the procedures for vertiports, but it's still based on some assumptions they have. It's still not based on the regulatory requirements. So that's the reason why I did not go in designing procedures for each of the site.
Okay. We can have one last question if there is any burning issue. But otherwise, we don't have anything online, right, Rafia? Okay. Then we can have our coffee break. No, first we can applaud our great partners. Thank you very much. So now we can have a short coffee break, and at 11:30 we come back here for the panel discussion. Thank you. Okay, we're going to reconvene. If you can find your seat. Hello, nice to see you.
Nice to see you. I didn't have the chance yet.
We're gonna start again. If you can find your seat in the room. Okay, please find your seat. We know that the coffee is delicious. You can take it with you on your seat. I put a clicker. Okay. Hi, Constantine.
Hi.
Sorry, I didn't have time to say hello.
Oh, no worries. You're busy. Perfectly understand.
It's all good. Thank you so much for coming.
Happy to be here.
Okay. Great. Thank you very much. So, after the coffee, we're going to have now the most exciting part of the event, which is the panel discussion, which our colleague Bezad has gratefully accepted to moderate. So, Bezad, the floor is yours.
Yeah. So, hello again, everyone, and thank you again for being here. Right now, we are going to have our interesting panel discussion. Yeah, so far we have seen how MAIA is solving the problems related to airport accessibility, and how we are doing research on the fact that the new modes of transportations like UAM and SESAR is going to solve the accessibility to airports in near future. But right now, we would like to hear from our panelists and have their insights and opinions on how these new modes of transportations like UAM and SESAR are evolving in near future in order to access to airports. So I'm going to ask from the first panelist, Sergi Alerj, to come on the floor. He's a Director General of the Airport Regions Council. He is a recognized expert in airport territory relations and EU-funded sustainability projects. Our second panelist is Daniel Molina from Bluenest. He is the head of operations at Bluenest, leading the developments of vertiports, infrastructures, and UTM integrations. Then we have Constantin Hoys from Brussels Airport. He is a strategic airport planner at Brussels Airport Company. He is combining 15 years of experience in aviation strategy, planning, and consulting to shape the airport's long-term developments. We have Tim Dekenek from LRM. He is a senior mobility expert at LRM, leading autonomous vehicle projects and supporting drone ports innovations. And last but not least, we have Tom Eric Kuhlen from MAIA. He's a senior transport modeling specialist at MAIA, advancing shared and autonomous mobility solutions through innovative mobility and consultancy work. So I would start by our first questions related to passengers and innovations. This question is to all of our panelists. So as we have seen in MAIA, we have tried to understand what types of passengers would use the new modes of transport like UAM and SESAR. So my questions to all of the panelists is how likely it is that air passengers would use these services and how we can influence their travel behavior. So any of the panelists could start, but I think Konstantin, you might be the best one to start with these questions on the airport passengers and how likely is that airport passengers would use these services. Please.
Yes, thank you, Bajat. This microphone is on, right? Yes. Thank you. From the airport perspective, we definitely believe that passengers will be using these new transport modes in the future. It's also something that we take into account in our master planning exercises. However, yeah, the extent to which the passengers will actually start using these services will depend first on to what extent they are aware of these services being reality, let's say. So we need to make them aware that it's not a science fiction future thing that doesn't exist yet. It's definitely coming in the near future. Secondly, we need to be able to convince them of the safety and the reliability of these transport modes, take away the fears, take away the thresholds, let's say, for using these services. And a lot of work is being done to actually, proof of concepts, research, etc., making sure that these new technologies work and bringing them to the wider public. And then the final point, I guess, would be the willingness to pay in the general concept. So not only the monetary value that they would have to pay for using these travel modes, but the willingness to spend their time. The new travel mode should be as convenient and as time saving as the modes they are using right now.
Okay,
that
great. So you mentioned that you already have this in your master plans in Brussels Airport. That's really interesting. So Sergi, would you like to add to that regarding the passengers and how likely they are to? Do you have something to add on the insights from Konstantin?
Yeah, thank you. First of all, thank you to Nomon and Polis to invite me to participate here. Thank you, in fact, to Juan and Manon, because organizations are organizations, but people are the ones who develop. And as I have been, I think I am the first one to take the floor during this morning from Catalonia. Welcome to Catalonia. And I realized that all of you have landed in my city, because you landed in the Barcelona El Prat airport. And I have been 27 years the vice mayor of this town there, this city, that you can go there for tapas, not go to Barcelona. My recommendation. Anyway, saying that, I think the factors are, first, the security. I think it was more or less, you didn't mention the word, but it's security, and not only security that I will not fall down, if not that I will arrive on the time they have promised me. The second one, it was mentioned too, is the price, how much I have to pay. And I think the third time is how much time I save, because for a passenger, it doesn't matter if I take a taxi or a train. I mean, it's commodity, price, time. So commodity is supposed to be there. If I can afford the price, then it's how much time I save to take something that it looks like not so safe in principle, like a train or a taxi or whatever. So this goes to the point of, to myself, is at least in Europe, the vast majority of the big hubs like Brussels, or medium hubs like Brussels, Madrid, the other case on the side of Berlin, they are moving more to the long haul, not to the short haul. The short haul and medium haul is between these big airports. Europe is focusing in train. Today, for example, there are the news that we knew it, that they are working already in the design of the project of the connection of the high-speed train with Madrid. Now you go to Madrid, but not to Madrid airport. Okay, and it's the same in Amsterdam, Paris mainly, and all that. This means, first, you are not so in a hurry. I mean, the people who are in a hurry are the frequent travelers business, but you don't go like that if you go to New York. You know you have to go to the passport control, blah, 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 plus the issue of the suitcases. I go to Madrid or to Brussels with a bag, but I don't go to New York with a bag. So this is too important to take of that. So altogether for me is that I think drones will be able to move a little bit of people, but mainly in the distance of 50, 60, 70 kilometers with not very good connections, that you have to make a lot of changes or some changes. And if you get your taxi, this is going to be very or as expensive as. And the saving of time can be important because you are coming from outside to the URB, to the metropolitan area, that you are not sure if taxi will provide you a good time.
Yeah, great. Thank you for your insights. So, any other insights from Daniel, or yeah, do you have anything? Oh. So you can.
Yeah.
Okay, please. Eric,
I just wanted to add to what you two just said, because we as MAIA have a ride-pooling service running in Hamburg, and we can use the insights we now have about our customers traveling to the airport and back, and use that information as we will step by step turn our now driver-based ride-pooling service to autonomous driving service. And we exactly see what you just said, that when we asked our customers what is the reason why they took our ride-pooling service and not an alternative mean to get to the airport and back, it was exactly reliability. So that's the most important part there, and also comfort. But yeah, comfort is not really reliant on the autonomous part. And what regarding the likelihood of people using that, I can add an insight that more than 50% already, without them being able to test it or us making a lot of communication in that direction, are willing to already use autonomous driving in Hamburg to get to the airport, but in general to get around. And 100% this number will go up significantly as soon as we start communicating more and more.
And how is the price related to taxi and other services?
It's in between public transport and taxi prices. It's always cheaper than taxi. That's the price thing we have. It's dynamic
and do you
pricing.
have any solution for solving the problem of level of service, like the luggage and these kind of things, for traveling to the airport?
The people are using our service at the moment because it's as comfortable as they wanted to have.
Okay.
So we have big enough vehicles for the luggage, for example, and our stop is, for example, directly in front of the terminal. So that also is very important for the customers at the moment.
Yeah. Tim, would you like to add something?
Yes, I just wanted to add that we have quite some empirical research that shows that people are quite willing to adopt these modes. Well, we are specifically talking about the autonomous shuttles. I'm talking a bit less about the drones. But we had a big project at one of the sites that LRM has developed. LRM is a Belgian investment company. And we had one of the biggest and most complex large-scale deployments of self-driving shuttles running there. So we transported 300,000 passengers with a fleet of 6 autonomous shuttles in a period of 2 years. So unfortunately, due to financial problems of the supplier, we had to stop the project a few months ago. But we did quite some user acceptance and experience surveys. And what we found was that people were extremely satisfied with this service. They were very willing to use this. They were very, very happy with this service. And also when we dig a bit more into what are these psychological concepts or constructs that define this intention to use this for their future everyday travel, including airports, but also other, there is one single component that's really stuck out, and that is the utility of the service. So to put it simply, if we make sure that the service is valuable to people, and valuable can have several components. It can be comfort, it can be speed, it can be cost. It will be a combination of all these. But if we make an appealing case for the people that is a good way to travel to the airport, people will use it. They will come. I'm quite sure of that. And if we want to build on this user acceptance the coming years, it's important that we do pilot projects so that people can have their first positive experiences with this. But it's also important these experiences need to be positive, because we obviously also found that when people have bad experiences, like technical issues, ghost braking, or long delays, that of course is a negative experience that then again reduces their intention to use these modes in the future. So we need to work on really valuable pilot projects where we can really show that these modes can be a real transport mode and not just a technology gimmick that we want to showcase, which unfortunately has been done too often the last few years when we talk about automated vehicles projects in Europe.
Yeah, so what I'm hearing is that you both are saying that these kind of services has got already accepted by the people. So the next step is to implement it in more scalable projects and because what I hear from your insight is that people have already accepted these services and it's ready for the next steps for a large scale implementation.
Yeah. We had 0.6% of people who did not use our shuttles who indicated that it was because they thought it was not safe. 0.6%. So virtually nobody. And that is, of course, today, and it's still very exotic. So the more people get used to it, and I mean, the acceptance, it takes 5 minutes. They get in, they're excited, they take a picture or a video. It's probably the same with you. It's the same with Waymo. And after 5 minutes, they're like, oh, this is actually quite boring. And they start scrolling on their phone. And that's what it should be. It should be a very boring, uneventful drive. And if you can offer that, it's fine.
Okay, that's great to hear these insights, but that leads me to the next question, which is on the operational aspects, because we would like to know how do you see the potential inclusion of autonomous shuttles and UAM operations from the airport perspectives and also from the shuttles and drone operator perspective. So my question is to Daniel and Constantin. So Daniel, do you want to have some insights on the operational aspects for inclusion of these kind of services into the transport to the airports?
Yeah, first of all, thank you very much for the invitation to participate in this panel with these colleagues that share the goal of this new mobility, which is very exciting. Yes, before emphasizing there's something that I would like to add from the previous question that about what is needed for the passengers. Well, you mentioned about the prices. You mentioned about the time, but also there's something that is important, the comfortability, how the user will experience this new mobility. So I think in every project for mobility innovation, I think before technology, we have to put the passenger first. So at the end, apart from saving time, apart from look for other alternatives for moving, the passenger will look for an experience which is easy, comfortable, and at the end he will say, okay, this works. So that is essential to build the public trust, which is something very important for this new concept of mobility, which is very new, of course. So from Blueness perspective, we are building the digital infrastructure, also the physical, for making this new air advanced mobility a practical reality in such a way that the airport and cities and vertiports are connected as one. So we provide services of mobility to the cities. So yeah, this is something that is important, but at the end, the airport will not be the final destination as we are used to see as up today, but at the end will be an active actor in the this new ecosystem of the new mobility. So this transition has to be as much smooth as possible. So that's quite important for us, and of course we have for that we also have to think of the technology and the digital platform, which integrates all the aspects, all the factors that have to be managed for this new mobility, as flight management, weather, security, energy, which is something that will have to be managed by the airport. The energy, not only the flight, but also the energy, the data, sharing the data space. So this is something that from Lunes we are also designing, and we have a platform which is called the Vertical Control Site. and from this platform, everything will be integrated, in digitally speaking. And also we have the infrastructure. We have recently, I've seen studies that have published, especially in the US, that in big cities with there are prime ruptures that have the price have increased considerably, even 4 times the footage meter. That's something quite valuable because it means that the cities are giving value, not the access to the access to the sky, not only to the access to the ground. So, and that means a challenge because the infrastructure is not that easy. It's not that placing a landing pad and that's all. We have to reinforce the installations in the cities. We have to provide the fire suppression systems, the charging systems, also the terminal passenger handle. So it's quite a challenge to make this new mobility a reality. At the end, the new airport, the future airports, will be built in concrete, but also in coordination and purpose.
And have you done any projects or collaborations with the airports in order to integrate your services in the airports, or not yet?
Not yet. We have concepts in terms of research. We have working actually in Europe. You know, it's just we need regularly clarity and interoperability yet, just to that for being defined. We are collaborating in European project research. And even we are exploring even in America also, because they are a step ahead. We have participated, for example, in a tender for Orlando that they are projecting a network vertiport for Florida, and we are pointing that in those sites especially. But Europe is we have to admit that goes a little bit slower.
Yeah. Okay. Then, Konstantin, how do you see the inclusion of these new modes in the operational aspects of the airports? If you want to add something to the points that Daniela raised.
Yes, certainly. Implementing automated vehicles to start with in the existing airport operations is, well, relatively easy. Why? Because an automated vehicle basically uses the same infrastructure that is already available at the airport. We have roads, we have drop-off locations, we have priority bus lanes that could be used by these vehicles as well, if that choice were to be made. So as long as these vehicles use the same basic infrastructure and are able to navigate free-flowing traffic, then nothing really needs to be done. Maybe we need to put a couple of charge locations, electrical charging points, but that's about it. Then it's more about regulation and the cooperation with the community surrounding the airports to make it happen. At Brussels Airport, we already passed one proof of concept of an automated vehicle on airside, and a landside proof of concept is going to start in the next couple of months. So that already goes to show that it is doable and relatively easy indeed to implement it in practice. We are strong believers that within the next couple of years we will have these services running as a basic part of our operations. When looking at eVTOL services or UAM, it's a different story because a lot more is needed to make that happen in reality. You need dedicated infrastructure with certain security clearances, certain bits of technology and infrastructure that have not been completely proven in reality yet. So you need more space, you need more investment. And not to forget, already mentioned as well, is the energy requirements, which are tremendous. It looks like, for the time being, at the very least, that for every operation, the vehicle will need to be recharged. And the peak power requirement that is needed for that is a lot. Just to give you an idea, if we were to recharge 3 or 4 eVTOL vehicles within 1 hour, it would require almost the same peak power as the entire airport of Brussels needs today. So just to put matters into perspective, you need a tremendous amount of energy, which needs infrastructure as well, and which needs the actual energy to be sourced somewhere. And if you cannot source it in a sustainable way, then why would you even bother implementing these things? So to sum up, automated vehicles, yes, very quickly within the next couple of years. UAM, it's going to take a bit more time, but in the end, the technology of UAM will take a bit more time to mature anyway.
And you see the challenge here for the UAM more the regulatory aspects or more the safety and the air traffic management aspect? How do you see that?
Yeah, definitely the safety aspect is being worked on. So let's say from a technological point of view, we are perfectly able to fly these types of machines. It has been proven already. And companies are working on further developing their prototypes. Regulation is definitely one of the biggest hurdle from the airport's perspective at this time. Nothing is going to happen unless we have a stable regulatory environment which allows us to make a prediction how these machines are allowed to operate at our airport in the future, regarding flight paths, regarding separation distances, regarding every potential detail of the operation needs to be cleared by regulation. And at this time, none of the intergovernmental bodies like ICAO, like EASA, let alone our own national aviation authority, are ready to teach us how to do it, let's say. And that is the main hurdle that we're facing right now. And as long as that is not in place, we will not study anything further in detail, to be brutally honest. Yeah.
Okay, thank you very much for raising this important point. You also mentioned about the sustainability aspect on implementing these new modes of transport. That leads me to the next question of the efficiency and sustainability of airports. So how can we improve the efficiency and sustainability of airports and then integration into local and regional transport systems? So Sergi, do you want to add something to that regarding the efficiency and sustainability of how we can improve the efficiency and sustainability of airports if we use such new transport modes?
Well, thank you. Not easy question, but before to go to that, maybe in this audience is not the best news, but two news. In the vast, if not in all capitals of Europe, it's forbidden to fly commercial helicopters because security, king, queen, whoever. I don't see that they will let drones. If they don't let helicopters with a pilot, he or she with the license and blah, 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 no one sees that they will let. So this put very down the potential demand for a business case. The second news, it's not, I don't know if you have heard them. People from Airbus telling you, we don't believe in drones for people in Europe. For people, not in Europe, not even eVTOLs, not even regionals. I think they make a mistake. They see it in Sao Paulo, in Shanghai, in big American cities, because our metropolis, maybe the only one escaping from that is London. But with 5 airports around, and then the drones have to make like something like that, because there are so many aspects of flying and security and so on. So I think we have to, one thing is that we are able to develop a lot of technology and a lot of models, but the other thing is what the people from the business have to count before to put more money on that. Talking about the potential integration.
Sorry, before going to that, Tim, would you like to add something to the regulation aspect, because it's a critical points that Sergi raised, and Sergi see that it's not that much, yeah.
It's not about regulation that I want to add, so I don't want to interrupt you either.
Oh, okay.
What I just wanted to add is that I really see your perspective on the eVTOL story, let's say, the electric vertical takeoff and landing, the drones. Yeah. What we have not addressed here yet is eCTOLs, electric conventional takeoff and landing, electric airplanes, basically.
Oh, that's another story.
And that's another story. Sorry, that is another story. That's a completely different story, and I think a very important and interesting one, because personally I believe strongly in this and in the role of regional airports for this. Yep. We see a lot of technology about electric aircraft being developed right now. At this moment, it's 2-seater airplanes, sport planes, training planes, etc. But it's going very, very quickly, and we expect to see in the next decade the 10-seaters or the 50-seaters being able to fly battery electric for up to 500 kilometers. Then what is today being banned, the short flights, suddenly becomes a very sustainable way of not only getting to major airports like Brussels or Madrid, but maybe also connect regional airports with each other. You can get to a system, and I know this will bring a lot of new complexities airside, obviously, but I think regional airfields could be a major provide feeder lines to national airports as a new and a sustainable way of getting to these airports. And I want to maybe contradict Sergi a bit when it comes to trains. I love trains when they're not delayed. We definitely need the train network that we have today. We need to optimize it. We need to make use of it as much as possible. But I don't really believe in new high-speed trains throughout Europe. Europe is so densely built and so strongly democratized that it will take us 15 years from today to get maybe a high-speed rail in place. It will cost billions of euros to build. It will produce a huge amount of carbon to create the infrastructure. And by that time, I believe we have performant battery electric airplanes that can make mostly use. There will be the energy story, which is a complex one, but they can mostly use the existing infrastructure. There are maybe like 3,000 regional airports in Europe that are strongly underutilized. The infrastructure is there, the runways are there. It's just a matter of small investments to get them up and running for this mode. And I personally strongly believe in that, and that's also where we at Droneport are heavily invested and developing in. So Droneport, a very unfortunate name that dates from a few years ago. It's basically an incubator about aviation technology that Brussels Airport and LRM are co-invested in. And we think that we really believe in this as a future transport mode.
So you're saying that using the current infrastructure for drone ports or using the current airports that are not used yet, you are saying that this kind of integration is much more sustainable rather than the high-speed trains?
Let's say as sustainable as high-speed trains. More sustainable is already a stronger statement, but at least as sustainable.
But with less cost.
But yes, and definitely I think a more sustainable way of getting around than eVTOLs, passenger drones, so to say. A passenger drone is basically an air taxi, one person, two persons, whatever. And an eCTOL is basically an air bus, not the company, but you know what I mean by the concept.
Okay, great. Seiji, yes.
No, the point is, it's not that I disagree with all of what you have said, that it could be, but I think the point is you have opened all the chapters. Because then it's, yeah, I mean, of course, one thing is drones, urban mobility, let's say regional mobility, and the other thing is the whole picture. First, it's whoever says whatever, including myself, of course, the first one, we are in fog. So we see, but there is still fog about what is the future of aviation. In fact, what is the future of aviation connected with trade, okay? But one thing is clear, Europe is putting a lot of money, and the message is quite clear. And if you combine that with the experience of to take a plane, some people think about a lot about why I have to suffer, okay? This is one thing. The other thing is you're totally right, but high speed is not in the French and Spanish way, the worst, in my opinion, if not the German way, or the Dutch way, or the Belgian way, but it's in the same tracks, trains that are much faster than the previous one, and the ones who save or don't stop so often, then the time is better for the final destination. If you see in the aviation, the fog, what more or less we can figure out is more people will get the long-haul planes, what aviation is. You cannot beat aviation in the long perspective with SAF. This is clear. That's why, I mean, you can see it in Amsterdam, you can see it in Frankfurt, you can see it in Charles de Gaulle mainly. People go there by train. Important, and connecting a little bit with your with the question. Integration is important of the modes of transport, but if you don't combine time and tickets, no one will take a train to go to Frankfurt, to go to Shanghai by train if you don't assure me I get this another flight if I arrive late. This is what's going on. Barcelona-Madrid has high-speed train connection. 95 of the people, numbers of Iberia, who is the one only flying between Madrid and Barcelona, 10 times every day. 95 of the passengers are flying to South America. You don't get the high-speed train, even if it's much better. It's downtown, blue, 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 blue. If you don't assure me that if I lose the plane because the train is late, I get another ticket for the next train. No way. No way. And it will happen the same with this. Then long haul with SAF, medium haul with hydrogen, and short and complicated areas, electric. I do really believe too, like you, in electric. But the point with electric planes going from Košice to Vienna is that they have to land like another plane, and Vienna airport cannot expand. Not Vienna, not Frankfurt, not Amsterdam, not Madrid, not Barcelona. The big hubs cannot expand because political and social pressure. So connecting regional, yes, if they are 300 kilometers, because they combine two things. There is capacity at the airports. Maybe there is never a good train, highest speed train with two regionals because they are not the capitals. And second, because if it is electric, the price goes down and much down, so there is a business case. If not, no way. To the answer that your question, I think the main thing is integration. And I think it has been mentioned, I'm talking only about drones, and not about, of course, the no driver buses. By the way, probably all of you, going back again to El Prat and Barcelona here, all of you had maybe got the metro L9. Yeah. It's no driver. It's very nice if you go to the front and you will see the tunnel, maybe for the first time ever in your life, going with that. I do really recommend it because it's like, wow, not bad, okay? And it's nothing, usually something that you cannot see in the rest of the lines and maybe in your cities. So it's really integration, because I have seen a lot of people talking about drones and urban mobility, that they forget that this mobility, and you are getting in an ecosystem. And the only way to really push is to say, well, we want to be integrated in the system, because what in the future, what we are working in Brussels, and I will finish in Brussels and Europe, is that I take this, I want to go tomorrow to this place, I buy one ticket, and before to buy the ticket, they will provide me time, number of changes, CO2, price. And then I will take it, and I will take one ticket for all. What is going on in a lot of metropolitan areas, Barcelona, by the way, the last one in the whole Spain, even if we think we are the best. This is a political advice, that advertisement I take the opportunity, but the last of the last. So this integration will go further and further. Even, and this is a big problem already, companies, it has been mentioned, they don't want to share their information. Because data, as you know, especially people from NOMO, data is gold. They don't want. And in that sense, I do really see that European Union and the different states, or all the states, have to be hard policer, making this obligation, because if we invest public money, we have to take the last profit, the maximum profit of these investments, public money. And this is just to tell the companies, you have to put it, all your information, sorry, on the table. Thank you.
Great. Thank you very much. It was really interesting to hear your insights. You mentioned that, the types of the passengers would be more sensitive to time, and taking if it is a delay in the train or something, then they won't take the that specific mode. So do you see, Sergio, also other UAM or something, they can increase this, they can solve the problem of time sensitivity? Any of the panelists, would you like to add something on the time sensitivity for the passengers, and also on the efficiency and sustainability? Constantine, you might want to add something.
Yeah, regarding time sensitivity, I guess, especially when you want to connect an airport to its surroundings, to its catchment area, you need to be certain that the connection between your new transport mode and the aircraft, which is your eventual goal because you're connecting to an airport, that you do not delete the time gain that you got in your transport to the airport, because you probably will pay a bit more when flying to an airport on a UAM, on an eVTOL. Maybe you will gain 10 minutes, 20 minutes, maybe half an hour. But if you then land at a location at the airport where you still need to walk quite a long time, or you need to take another transfer, and you don't gain any time in then reaching your check-in or the aircraft in the end, then what's the use of taking the UAM in the first place? And that again goes to show the integration that is so important, and the cross-border part, the cross-border cooperation, not necessarily international borders, although that's required as well, but just the cross-border between companies and between the airport and the community surrounding its perimeter. That's so tremendously important indeed in exchange of information and data, in making sure that schedules are aligned, in making sure that the complete door-to-door journey is optimized. That's going to be required, because otherwise, if everybody keeps working on their own island, there will still be gaps, and then your time gain, which is such an important part of this entire story, will be undone at another point in your travel.
Tim, yes.
Yes, so 110% agree on the integration. I'm still waiting for this one super app that will integrate all of this, and maybe with all the AI developments we have now, we might get into this, although AI will not just solve everything by itself, but okay. When it comes to travel time, I agree with you, Constantine, but maybe even more important than absolute travel time is the how certain you are of your travel time, the reliability and the accuracy of the travel time estimates. Why do all of us come 2 hours in advance to the airport, and the more conservative ones, including myself, usually aiming at 2.5 hours before? Not because we like the restaurants and the shopping so much there, but we want to be certain that we are in time. And if there is a mode that is 100% guaranteed that it drops me off at the airport 90 minutes before departure, but I need to pay more for it, I will take it, because then I am sure that I can gain that hour without risking to miss my flight, which is the worst case outcome that I can have. So the certainty and the reliability of this travel time, that will also be a key feature in the utility and the value for
and you're talking about which mode? Which mode do you think that could have such potential to increase the certainty?
It will all depend on how it's integrated. Indeed, drone taxi might be it, depending on where it can land, how it can be connected to the terminal, how reliable you are that it is. Could be automated shuttles, depending on how certain you are that they don't get stuck in regular traffic. Could be all of them, depending on how reliable the technology in itself is and how well it is integrated in the whole airport ecosystem, I think.
Yeah, great. Is there anything to add from other panelists, or?
Well, maybe one more thing I wanted to add regarding integration is that it can help build the business case in the end as well. Because at an airport, in particular at Brussels Airport, we have one major traffic peak in the morning. So from the early morning till about noon, you'll have a lot of passengers either going in or going out of the airport, but then you have really a low demand period during the day. And if you have a properly integrated transport system with the surrounding communities, then your vehicles can be used elsewhere, making it a lot more profitable to actually roll out that program. And if it's only reliable on traffic to and from the airport, you will always have down periods which can destroy value in the end.
Great. So far we have heard about some of the challenge that we are facing for implementing UAM or SESAR. We have heard about the regulation aspect, which is one of the big challenges, and also we have heard about the integration challenges amongst other on the challenges. So that brings me to the next questions regarding the what are the main challenges and priorities to support the deployment of the autonomous shuttles and UAM services, and how we can improve these challenges and solve these challenges in local and regional ecosystems. So my questions is to all of the panelists. So we can start with you, Tom Eric, if you want to add about the challenges and priorities for these modes.
Yes, 100%. So I want to start with that. Level 4 autonomous driving vehicles, their reality, they're there, but the pace is set at the moment from the US and from China. So I would say the priority should be that we in Europe try to be more independent from the US and China, and to do so we need regulations, which we talked about already, which are more favorable for autonomous driving vehicles. And we need to boost the technology maturity of the technology we have from European companies. And one way how this works is that we see our European way of doing things as our unique value proposition, so that we steer the integration of autonomous driving vehicles so that they serve the common good. For example, as when we integrate them into the public transport system, and have them also as a ride-pooling service, have it more attractive to operate them as a ride-pooling service than as a ride-hailing service, so they can make the transport system as a whole more efficient than it is at the moment, and not make the problems we have in the big cities bigger. I would end with that. So I would say that that's the main priority we should go, and the biggest challenge are the regulations and bringing the technology on the streets.
Okay, great. And to continue with that, also to the other panelists, how can we solve this regulation? It should be solved on the European level, or it should be solved on the country by country, or how do you see that? Yeah, my question. Yeah, probably you, Daniel, wants to add something.
Yeah, I think it's important to mention that we have up to now we have reached a point that the technology is not longer the main challenge, but the alignment of especially the regulation. Yes, I think we have proven concepts through many projects that we are working on, research projects, European projects. Also, we have gathered operational know-how through those projects or the different iterations that we have had. And also the aircraft certification, which is a very important leg, is on a good track. Let's say that, okay, in European manufacturers are no longer in the market, but we have the US manufacturers, also China, even we have another company which is Vertical Aerospace, which is British, but okay, it's a good track. So I think what we lack is a common framework just to help to scale this safely, because here the regulation in Europe, I think my perception is that it is very fragmented, and every country is progressing at its own pace. And without a coordination, I think all these projects, we turn into risk that all this innovation will turn into isolated concept without and ending nowhere else. So I think that's quite an important thing, and that's also a good opportunity for Europe just to look for a common model of this new advanced air mobility, just for scaling safely. So another point which is quite important is, of course, that's already mentioned, is the public trust. We need to convince the people that this is something beneficial, that is transparent, that is safe, and also they will see the advantages, saving time, saving, of course, that is beneficial for the whole community. An initiative like this, like MAIA, I think they are quite important because they are bringing evidences, they are bringing data, they are helping the authorities just to build the rules with not with suppositions, but with data. I think that's quite important to mention.
But I think, Tim, you mentioned that the public trust challenge is already solved somehow. Is that true, or how do you think?
I wouldn't say solved, but it's probably less of a challenge or issue than we may think, because now and then we get this news headlines that say like, oh, there was a general poll with 1,000 inhabitants and 40% are scared of automated vehicles. I mean, yeah, these polls, they don't make sense. You ask people like, hypothetically, there will be a vehicle that drives itself, and hypothetically, it will look like this and this and this. Would you feel safe using it? I don't know. I've never seen it. I've never used it. What we do see is that if people see it and they get too used to it, trust and acceptance is extremely high and almost immediate.
And do you see any other challenges apart from these ones?
Well, I think most challenges are already mentioned. Well, the ones that I had on my list were all covered very well by Tom Eric. Thanks for that. No, make sure that we get to less vehicle kilometers instead of more. That's the big challenge. We don't want to be the new hotspot of robotaxis. Let US and China do that. It's fine. We want in a more sustainable, integrated way. Regulation, indeed. I've talked to many suppliers in America and China about their expansion plans, and all of them say basically the same. We're very interested in Europe. It's a very promising area, but it's such a patchwork of small countries with all different procedures and exemptions, and we don't understand what to do. So basically that is holding them back to come to Europe. Geopolitically speaking, is that something bad? Is that something good? Open discussion. The conclusion is that today, America and China are, in terms of technology, leading this race. And this is definitely not something that I want to say to minimize MAIA's work, because MAIA is doing excellent work, but even MAIA is also not fully European, but also integrates international technology. So the question is basically how sovereign do we want or need to be in this? Is it a problem for us that the AV technology is American or Chinese, but we integrate it in the European way to bring the benefits to economy and society that we want? I don't think that has to be a bad thing. Think about our smartphones. We used to have Nokia. Europe was the heart of telecommunication. Then an iPhone comes in, and a few years later, all phones have dramatically changed. They are all with American software. They're all built in China. But I don't think there's a single European company that doesn't make use of this and that doesn't see any benefits in this in terms of how they do business for efficient communication, new marketing, new business models, etc., etc. And I think we really need to think, geopolitically speaking, maybe we should get over this sudden fear of, oh no, dependence of American technology, dependence of Chinese technology. Okay, is it a risk? Yes, but I don't think it should be holding us back to say like, okay, let's keep this technology out, because it will set us back 5 to 10 years probably before we can reap all these economic and societal benefits.
Yeah, great point that you mentioned that. Yeah, so what I hear is that we have to use these technologies, but in parallel, we in Europe should work on being independent, but it doesn't mean that we have to stop using these technologies. We have to use these technologies, but
and that's exactly what MAIA is strong in.
Yeah.
They don't need to fully invent this full AV stack. They are a mobility company.
Yeah.
They are searching, correct me if I say stupid things that are wrong, but they are searching of how can we use this technology to transport people in a sustainable and economic and comfortable way. And that is the key challenge that we should solve, I think, rather than per se wanting to solve the technology challenge itself.
Tom, Eric, would you like to add to that?
No,
Okay, great.
Exactly correct.
Okay, yes, Sergi, please.
That was a tricky one.
Regarding the first question, if it should be European level, totally. I mean, for two reasons. As ARC, we are participating not in the advisory board, if not as a full member of another project of drones. And the other day, they put us the example, they show it. A drone, a normal drone, not small, not big one, that you use in Bratislava, in 20 minutes will be in 5 countries. So if in any country there is a different legislation and blah, 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 go away, dead. You are completely dead. So, and the second reason is that it's from new. I mean, a lot of work in Brussels is that you have to make puree from 30 different vegetables, because every country has different vegetables, I mean, different legislation, but you have to try to put, and as you know, there is status quos. Do you know something about Euro controllers, of eye controllers? Why we have so many problems? Because every one of them have their own status and their own regulation and their own salaries. This is the only reason, and maybe I will not say outside of the room, but of not to have a single European sky. Because the other thing is, like, in drones, technique can solve, it's already there, but it's another problem. Maybe it's a good problem to have human problems and not only technical problems, okay? But I think the main challenge, going back to the first question of this last part, is that the sector, the sector should first take it easy. I mean, aviation and airports is a very, very, very much conservative ecosystem for two reasons. Because every movement, every decision to be implemented has to be, for the first day, international. Because in Brussels now there is a plane coming from Barcelona and a plane coming from China, and in 5 minutes later a plane coming from Brazil or from USA. So this takes plenty of time to be regulated. And the point is, after every technician, every CEO, every head of department, there is a lawyer, mainly from the insurance company, who asks who pays this if something goes wrong, because your technique is genius, but one day, like all technologies, will fail. Who pays? And then it's like, ooh, bye-bye. It is like that. This is the game. I mean, this is another game. So I think the sector of drones in general should be conscious that this is probably the most conservative sector. The second one, I think, in order to, even with this ecosystem, to go further, is that the sector has to demonstrate the added value, and has to convince not only the politicians, because the politicians will not move. There are plenty of priorities before to regulate drones, I can promise you. But millions, of course, and the business cases, because politicians move because social pressure or money pressure. And to tell you the truth, there is not any of them on the table. This is the truth. Talking about business cases. So we were talking before with a friend from Catalonia government. The first drone vertiport in Spain is in the airport of Lleida. It's one of the airports not in the hands of AENA. Has a permission of pilot proof. The reason is that but they are operating normal. Why? Because the national government has not yet the legislation approved. So it's like, I have not the legislation approved because I don't know about the topic, and I don't know about the topic because I cannot approve you because a proof is signed, and the one who signs takes the responsibility. This is the game, not only in drones. So the politicians don't push the guys who have to work, and the Congress of every country make the legislation because they have no pressure. So the sector has really to show added value for society, because this is the game.
Yeah, please, Daniel.
Yeah, specifically they are talking about added value. I think that's because quite important just to show the impact on people, what the new sector has. For example, and it's important to make a smooth transition, starting from logistics, but not only logistics as cargo just for transport Amazon packets and that's all. But for example, we have carried out demonstration in Canary Island, in La Gomera, and also in Madrid, transport of medicaments for health logistics, that is something quite important that you can see the people can perceive the added value. It will be beneficial. And in such a way that the politician will feel that pressure that you are mentioning, because this is something quite good. So I think it's important that we make a smooth transition, starting with those use cases, cargo, health, logistics, and also establishing safety corridors just for starting those pilots, not just to be linked to a specific, sorry for the micro, for the for the specific research projects or European projects which are funded projects, which is something very good because we are proving capacity, we are, as I said, gaining operational know-how, but also just to have that permanent, let's say, like sandbox, just to demonstrate people that they can trust on this new sector.
Great, great. You mentioned that there should be some cargo application as well. Have you done that in Brunei?
I wasn't specifically talking about application, which is it can be developed eventually, but just to define flight corridors, just to establish those sandbox, just to prove the capacity and to show people not only in isolated scenarios that we have done, for example, between the hospital Carlos III and La Paz in September, or even in Canary Island in La Gomera by May this year, just to transporting, just reducing significantly the transport time from on ground 45-50 minutes to 9 minutes by drone. So.
Okay, great. Konstantin, do you have something to add on the challenges and the priorities?
Yeah, maybe as a closing remark from the airport perspective, we've talked a lot about the hurdles and the question marks that are still there. This is definitely preventing airports from making any concrete steps at this time, because when you talk to any board member of an airport, and in particularly privately run airports, you need to make the business case work before any move is going to be made. As long as there are too many question marks, then nothing is going to happen, to oversimplify things. So I would just like to make the point to acknowledge the efforts that initiatives like MAIA are making to clear up some of those question marks, to make the fog, as already mentioned, disappear a bit more and to make things more predictable. Predictability is going to be key for those private companies to actually stick out their necks and do something in the future.
Okay, great. So with that, I would like to close this session. Then we will have 10 minutes of question and answer. So far we have heard on the so many challenges regarding the regulation, regarding the integration of these new modes, how we would integrate, and like the super software that we can have with our mobile phones, that with one application we can buy every ticket to all together with the time and everything. This is one good example of the integration. Also, we have heard on the sensitivity to time, which is a really important point when we are talking about these specific destinations like airports, because of course the passengers don't want to add more uncertainty to their trips. If these new modes of transport add more uncertainty, then it's not going to be useful modes. Also, regarding the technology, as we have heard, the technology is already there, but it's the matter of big scale integration, and it's the matter of regarding how Europe should react is, we have to, in parallel that we are using the Chinese and technologies from United States, we have to develop our own systems. And the final regard from Konstantin that, as an airport operators, so far they cannot have concrete steps, and so we have to wait for the regulation on a European level to integrate these new modes. So I would like to ask for applause for our speakers, please. And then now it's time for the questions. We have 10 minutes for the questions and answers. So please, if you have any specific questions, raise your hand to our panelists. Yeah, I see some hands.
Yes, Nuria Meerschaert from Bex Innovation. So I was wondering, you mentioned the challenge of regulations. How do you think that these challenges can be overcome? Do you think it's more from the EU side that this should come, or do you think that countries just need to coordinate better, talk better? Like, what are your solutions to this regulations challenge?
Yeah, who wants to add? Sergi, probably.
My modest opinion is it should be European level, because it's new. So it should be from the beginning. If not, again, we will have, from Brussels, they will have to make a puree of different legislations, and you will suffer, the operators will suffer them for a while till someone say, oh, we have to coordinate, so better to have it. It's very, and the one thing I take the opportunity, remember that Brussels is nothing. I mean, Commission is only one part of the triangle. The main decisions are taken by the triangle of Commission, Parliament, and the Council, mainly our governments. I'm up here of hearing, when I come back here or in Brussels or another country, it has been Brussels. Yeah, okay, it has been the Commission, yeah, but what your minister vote at that day, what that was the proposal, because Commission it's the executive. By definition, okay, they make a lot of proposals, they have a lot of money, but they are developing what mainly the Council has decided, mainly the states. And I don't offend them, I mean, the Commission has a lot of, but the reality is like it is.
Yeah, and maybe adding from an aviation specific point of view that we already have well-established pathways to install new regulations and new standards and operating procedures, etc. So that's going to go that same, well, let's say de-escalation, because it starts mainly at the ICAO assembly, going down to the regional intergovernmental bodies like the European Safety Agency, EASA, and then trickling down to the national level. So it makes sense to indeed, because it's a new topic, start off from the highest level and then work your way down.
Okay, great. And Tim and Tom, Eric, how did you solve the problem of regulation in your real implementation, and how does it work? I mean, you have the work with the region. I mean, you have the permissions for having such services on a city scale, or it was from the government, or how did you solve the regulations for implementing those modes?
These are at the moment country-specific regulations we use there, and Tim already said that it is at the moment not attractive for Chinese and US self-driving companies to come to Europe because of the regulations. So yeah, 100% it should be on European level to make it attractive to operate and bring the vehicles to Europe.
Yeah, basically every country has its own exemption type of procedures. So by default, you're not allowed to drive a self-driving vehicle, then mostly I'm talking about, but there is an exemption procedure, and if you follow that, then you can do that as a sort of pilot project. And that has worked reasonably well for some years, but today we are at the point where it's no longer about small-scale pilots or a small demo project. We are letting that phase behind us. Now we are talking about big companies, big money, who want big deployments, real deployments. Waymo doesn't come to Europe with a truck with 5 self-driving taxis and have a test project of 3 months in Brussels. No, they want a local partner who invests 100 million euros to roll out a fleet of 100 taxis permanently and not as a test project. And that is the scale that Europe needs to solve. That is beyond the scale that individual member states should solve.
Is there any other question? Yes.
Just a small question. Hello. Just a small question. So I'm new to this MAIA platform or these types of connectivity. How do you convince normal passengers when they could take an S-Bahn or a Miles in Hamburg that is also kind of electric to go from city center to airport, or like take an aero bus in Barcelona, which is also electric and technically more sustainable and also faster to reach airport compared to, and also expensive wise. Also, it's quite cheap to take an S-Bahn or miles a car or a aero bus. How do you tend to attract them with these new modes of transport?
Yeah, thank you for that, Christian. So what we see in Hamburg, or what fits to what I said at the beginning, why the people in Hamburg using MAIA to get to the airport, the main two reasons are comfort and reliability. And for the comfort part, I guess with big luggages, it's just much easier to get into the MAIA and then drive to the airport and not have to switch to the S-Bahn, because most people don't live exactly at the S1, bringing you to the airport. And then the second part is then reliability, and that part is also very important for them, and then that's probably the reason why they don't want to take their own car, because maybe they cannot park directly in front of the door. Parking at the airport is expensive as well. Car sharing the same. You need to find a car sharing vehicle. It needs to work probably. Probably these reasons I want to put into that.
From a societal perspective, I would say that we don't want them to compete with the S-Bahn and other sustainable modes that are there. We want them to compete with private cars and private taxis coming to airports. If we have a sustainable mode like an S-Bahn that works well and people are using it, by all means we need to continue working on that. And we don't want 100 people to get out of the S-Bahn and go into 25 MAIAs. We don't want to. Of course, I understand from a business perspective you wouldn't mind, but society doesn't really want that. But a company like MAIA, like ride sharing, ride pooling, that can fill in the gaps that cannot be met by these mass transit modes that are there today. And that is how it can compete with private car and private taxis, which is today by default what is filling in a lot of those gaps that are left.
I 100% agree with you. So we need to integrate the ride pooling into the public transport. And also what we saw when we asked our customers is that the share of people which would use as alternative traditional public transport is 25% less for the trips to the airport and back. So if you will, with the perfect public transport, at the end you will not get all the people inside the public transport, even though that would be the best for the society. You need something in between the private car or taxi and the public transport, which is as efficient as possible, but also needs to be more comfortable than a traditional transport is at the moment.
Yeah, because I think, complementing, if I may, the questions to your answer. At the end, who takes a flight, or why do you take a flight? You take a flight for business, so you take a taxi. The company pays. And if not, you tell the company you fly, not me. Second, you go with your family, usually. If you are alone or in a couple, maybe young couple, you fly and you take care of the money. But if you're a family of 3, 4, I know classical families of 4 are going down, but still a 6, you are with the suitcases, you're going to get again a taxi. Most probably you're going to get a taxi, because if you put all the cost with this taxi of here in Barcelona, 20, 25 euros just, or in Madrid, 30 euros, it's peanuts. Because one thing that we are doing not so good as a society is the penalty to get the bus or the metro or the train to the airport. Here in Barcelona it's 5.75. Maybe you pay yesterday. As you know, I know by memory because I use it. It's only 2 stops to my house. So 5.75 by 4 is the cost of the taxi. Except, of course, if you go 50, 60, 70 kilometers, if you go downtown. So you have to carry to go down to the metro, wait for the metro, go into the metro, go out wherever in Barcelona, and go to your hotel apartment or your family. Better a taxi. So we say the cheese of the different parts of to reduce the taxi and the private car is really hard.
but not, you can add, and it's good to have a transport system integrated from all points of view, timetable, ticketing, and so on. But there is really, I think it's very good options, the ones that are developing, because there is this target. It's very difficult to transfer. Talking about going to the airport, not other movements in the urban area.
Is there any other questions? Or online people?
Online question.
So yeah, I think we can close the session. Thank you very much, and we will have lunch in a few minutes.
We have one last presentation. But we can give a huge round of applause to the panelists. Thank you very much. Okay, I'm sorry this is not the end yet, but we're very close to the end and to the lunch. As you see, I put the agenda. Don't pay attention to the timing. You can only pay attention to the lines. So we just finished that part here. We're going now to the presentation of the MAIA white paper, which I promise will be as short as possible, and then we conclude the event. The MAIA white paper is important because this is a summary document of the results of the project and how to exploit them beyond the project lifetime. This document, this is a test cover picture, okay, so this is not a final, a final document, but, well, it's beautiful, so you can make pictures. The MAIA white paper is aimed to be a 25 to 30 pages document, so rather short considering the amount of results that we had. The objectives of this document is to provide a high-level view of the main results of the project, to promote the conclusions of the project and the recommendations that are deriving from the conclusions, and to support exploitation and further development by the target audiences, which we sincerely hope that you are part of. The timeline, the document is going to be submitted to the SESAR Joint Undertaking by end of November, so by end of this month, and will be then published upon approval. So you will receive it in a few months when it's going to be approved. I'm just going to summarize briefly what will be in the MAIA white paper. So it's going to be structured in 5 main parts with an introduction and conclusion, and then 3 main parts based on the 3 main results that were presented earlier. So MAIA-ENGINE, MAIA-CCAM, and MAIA-UAM. I'll be brief on that because we don't have that much time. The idea is mostly to focus on the relevance of these tools for society. So we start from the passenger's perspective in terms of airport access to understand what are the challenges and what needs to be solved. So the second part, when we focus on MAIA-ENGINE, the second part is about the expected changes with UAM and CCAM, and the last part is about what the tools that we have developed can do and how it can be used also in other contexts beyond the project. When we talk about MAIA-CCAM, yeah, we focus more on the functionalities of MAIA-CCAM that can be used also beyond the project. So yeah, supporting the assessment of the CCAM airport access services in terms of their ability to plan demand and anticipate it, and then in terms of their ability to measure the quality of service of CCAM services. And finally, the capacity of MAIA-CCAM to support cost analysis and anticipate disruptions of the service. And finally, yeah, the part on MAIA-UAM, again, trying to bring forward the aspects of MAIA-UAM that can support exploitation beyond the project. So MAIA-UAM is assessing potential vertiport location sites based on the service characteristics, UAM services, and the operational constraints. So we have one part focusing on the required service characteristics based on demand, and then, yeah, on service purpose and type, and on user profile, expected user profile. Then the second part is focusing on the operational constraints, and this is where we focus on the vertiport size and capacity that Bojana presented. And then the last part is about how to improve efficiency and bring it as a reality. Yeah, discussing business model challenges and also citizen acceptance and demand, because we saw that public trust is also a key aspect of their implementation. Yeah, this is also a summary of the conclusions. What is important in the conclusions is the last part, future research needs, which is aimed mostly, I think, at the SESAR Joint Undertaking to fund further research on the topic.